And Assalamualaikum, my name is Uthm. So today, me and my team, which consists of another 3 person, which is Muhammad Aidil, Muhammad Aiman and also Muhammad Hairi, are going to present about the application of Lagrange interpolation polynomial and also Newton divided difference. So the first thing is, what are we trying to solve? We are trying to solve a problem where we need to find the value within two intervals, which is A and B. We need to find the value in between that, and also the second question is, why do we want to solve this problem? This will help because this will help in finding the value between the table, or when we don't have the data that is needed, or for an example, we have the data of April and June, we can predict or approximate the data at May. So where do we get the problem or the paper from this for this problem? We got this paper that is it's written by Thomas Stoy and also Carol Francis Zach Abramack on the paper on application of the polynomial interpolation method for determining the performance characteristic of diesel engine. And so I'm going to pass you to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aidil bin Kamaluddin, and today I would like to explain about the method that we use to solve this problem, and how to solve this problem using the Lagrange interpolation method. So let me start. So for this part 2 report, methods 2.1, what is the suitable method to solve the problem? So actually there are many methods that we can use to solve this problem, but here we're going to use two methods, which is Lagrange interpolation method and the Newton divided difference method. So here how we solve finding torque for 1600 rpm using the Lagrange interpolation method. So we are using the fifth order. Basically it just seems like a different, but we have to modify the formula from the quadratic approximation 4 order. By modify this, we can find the torque for certain rpm. So in here, the example of us solving finding torque for rpm 1600 using the Lagrange interpolation method fifth order. So this is the solution. Then we will get the answer 0.179. So to find the different torque at different rpm, we just use the same step and we will get the answer, and this is all the answer. Then next we need to find we need to use the Lagrange interpolation to find different thing. For example, effective power, fuel consumption and specific fuel consumption. So this is the solution using Lagrange interpolation method to find power efficient at rpm 1600. So this is solution. We will get the answer 30.4059. Then just we use the same step, same solution, same formula to find the different rpm, and this is all the answer of it. Next, let me see how to find fuel consumption using Lagrange interpolation method. So use the same step here. Here is solution. Then this is the final answer for rpm on 1600, and this is the answer for different rpm to find fuel consumption. Then we proceed to the last one, which is finding the specific fuel consumption using Lagrange interpolation method. So this is the solution. Like I said, all same. Just repeat the same step. Then we will get the specific fuel consumption for rpm 1600 is 264.38. This is the answer for different RPM. So that's it from me, how to solve this problem using the Lagrange interpolation method. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Ahmad Syukri alias Uthm. I will present about the Newton divided method for this assignment. The other method that we use for the assignment is the Newton divided difference method. As you can see, this is the example question that we use for the assignment. The question is calculate of fuel consumption by using Newton divided difference. Find B kilogram per hour at 1600 rpm, 2000 rpm, 2400 rpm, 2800 rpm and 3200 rpm. So at the 1600 rpm, we use Newton divided difference method. Step 1 is make the table here. The number of function is depend by number of x. If x have 6 value of number, that means function have 6 value of function. Step 2 is write the formula. The formula for first Newton divided difference and enter the value and we will get the answer. Step 3 is also the same as the step 2. We must write the formula, enter the value and we will answer. But the number of formula will be decreased by 1 every function we use. That means that for the example, first Newton divided difference, we have 5 formula. But the second Newton divided difference, we have 4 formula. For the third Newton divided method, we have 3 formula. For Newton divided method, we have 2. Newton divided method, we have 1. Step 4 is repeat step 3 until we get one formula function. Until we get the one formula function like this. And after we get it, we must complete the table here. After we complete, we must move to step 5 is write the formula. Write this formula and enter the value that we will use. The value that we use only in here. After we enter the value, we will get the answer. And for 2000, 2400, 2800, 3200, we use the same method, step 1 until step 5 to get the answer. This is the final answer that we get for the Newton divided difference method.
Okay, so I am Muhammad Hairi bin Hashim. So for now, I am going to present about result and discussion part. Using the Lagrange polynomial interpolation method to find the effective power, top fuel consumption and specific fuel consumption for the 1600 rpm, 2000 rpm, 2400 rpm, 2800 rpm and 3200 rpm. For the 2000 for the 1600 rpm, for the fuel consumption effective power we get 0.179 kilowatt. For the top we get 30.41 kilonewton meter. For the fuel consumption we get 8.05 kilogram per hour, and for the specific fuel consumption we get the 264.38. So as for the 2000 rpm, 2400 rpm, 2800 rpm, and 3200 rpm, you can see as the table here. And for the Newton divide difference method, by the result, by using the Newton divide difference method, you can see that the result is the same as the Lagrange polynomial interpolation, because the Newton divide difference is an alternative method for the Lagrange polynomial interpolation. So the result we get will be the same. Okay, this finding is important for the people that work in collecting data, because this finding give us a chance to estimate some of the data may not be able to collect. The estimated value may come for a calculation and not for the actual data collection system, but the calculation data may give an overview on what happened on the interval of two data that we collected.